Okay, now let us come to the next discussion on example 4.2, which states that determine the position of the centroid of I section as shown in the figure 4.21. Okay, so divide the composite figure into three simple areas. Rectangle is, let us see the figure first. So this is one rectangle of 10 into 2, and then you have another rectangle of 25 into 2, and then this is the bottom one is 15 into 3. Okay, so this is three areas, and the only difference between the first figure and the second figure is that in this all the CGs they are lying in the y axis. Okay, so we may not worry about finding out the y position because ultimately this will be on the y axis or only, and for the y axis that means the x position is fixed. Okay, but we need to find out the y position, so distance from the x axis, that what I mean to say. So first of all, we consider this the bottom line, that is LL line, as a reference. Okay, and we find out the distance of each area, CG, the distance of the CG of each area from this line. Okay, so let us first take this top area, which is 10 into 2. So rectangle 1 is 10 into 2. Then you have it's a centroidal distances, you can see, so 3 plus 25 plus half of this, so 28 plus 1 29. Okay, and this is recorded over here. Then for rectangle 2 it is 25 into 2, the middle one. Okay, so the distance of this from the bottom line, that is the LL line, is 3 plus 12.5. Okay, so this comes out to be 15.5. And similarly for rectangle 3, which is the bottom one, it is 15 into 3 is the area, and the distance from the line LL, which is at the bottom, is 1.5 only. So, and similarly we can calculate the AY for all these. That means area into the y distance from LL in centimeter, and then sum those up, all these three, and ultimately finding out using the equation that we discussed in the first video. So this division will provide us this is the total AY, summation of all AYs divided by the total area of the figure. So this comes out to be 12.37, which is the location of this centroid. And as we discussed earlier, that the x position is on the midline only, so we need not to find that. And this is about this figure, this example. And next example is using the analytical method, determine the centroid of gravity of the plane uniform lamina shown in figure 4.22. So this is the next example. So in this you can see you have multiple areas which are connected together to form this composite area. So first one is this triangle that you are seeing, and then second area is a semicircle, and third is a rectangle. So procedure that we will be using is the same as that we used in the first example, or that we discussed in the general case in our first video. Okay, so in this you see in this table all the areas and their centroidal distances in x and y are given, and then we will multiply this area into centroidal distance to find out ax and ay separately for each of the areas, and then find out the sum total and divide those with the total area to find out the x and y location or x and y position of the center of gravity. So with this triangle, as you can see, it is area is 5 into 5, that means b excuse me, 5 into 5 is the base, 5 is the height, 5 into 5 divided by 2, centroidal distance from the leftmost and the bottommost. So this is LL and MM. Because in solving in these examples, if you take this uniform convention, that will be easy for solving these solutions. So in each of the examples, the bottommost and the leftmost is taken to be the reference point, and we'll find out this is distance 2.5 plus 5 plus again 2.5, so this is 10. And y distance is this is 2.5 plus 1 by third of 5, so 5 by 3, so this is 6.67. And this is the total ax for this triangle and ay for this triangle. Similarly, for semicircle we have pi r square by 2 is the area, and the distance from the uh, uh, leftmost point is for this semicircle, it is 4 into r divided by 3 pi is from the diametral axis. Okay, so from the leftmost it is 2.5 minus 4 into 2.5 divided by 3 pi, which is 1.14. And the y distance is 2.5, and these are the ax and ay for the semicircle. And for rectangle, again it is simple only because it is lying at the center point, so simply we will make half of this in the x side and in the y side, and find out the total. For x it is 2.5 plus for rectangle 5.5 2.5 plus 5, so 7.5, and y is basically 2.5. so this is the summation of all these areas into x location of each of the figure and sum total. And here we find out the x location and y location of the composite area. Okay, so next is example is determine the location of the centroid of the plane figure shown in the figure. Let us see. Okay, so this is the figure. So here the only difference is that you have the cuts. Basically this circle is a cut and this semicircle is again a cut. So we have to use the areas where you have the material, that will be basically the positive, and the cuts will be represented as negative. So all the other procedure is the same. Okay, we'll find out the centered location of this rectangle, and then for circle, but we will use for circle we will use negative sign, and for circle the location of the centroid is at the center point, we can easily find out. And for semis, for this quarter circle, for a semicircle it is 3 by 4 sorry 3 r by 4 pi. And for quarter circle, we can see over in this table again. For a quarter circle, it is half. It is basically the same 4 r divided by 3 pi, both in x and y. So it is because it is not at the center. So for semicircle it is basically the x location is at the center and y location is 4 r divided by 3 pi. So for quadrant we will use 4 r divided by 3 pi for both x and y locations. So that we can apply over here and find out the same thing ax ay for each of these figures and sum total. And here we will find the x and y position of the centroid of this figure. Okay, thank you.